All right, now say you're given an x and a y. Excuse me, I gotta find the marker. Hey, would you look at that? I found my eraser too. Okay, use this nice pretty pink right here. I hope y'all can see it. Okay, so say you're given an x and a y coordinate. Right? And switching back over into polar coordinates, we know that based on our triangle, once again from trig class, we use this Pythagoras. I'm not going to call it that. I don't like calling it that. Somebody did it way before Pythagoras, but anyway, we call this the Pythagorean theorem. If anybody refers to it, this is what they're talking about. So we know that from our trig class that x squared. Oh, that's not good. You can't really see that. Need something better. We know that x squared plus y squared is equal to r squared. Right? So if we want to solve for r in our equation, right, then r is easily found by just taking the square root of both sides. Wow. Ta-da! Right? And after you solve for r, it's easy to solve for theta, because once we have r, right, we can take either one of these two equations. Let's take one, right? So we know that the x equals r cosine of theta, and we're solving for theta, remember? So we're going to divide by r, right? X over r equals cosine of theta, right? And all we have to do is take the arc cosine, or the anti-cosine, or the cosine to the -1, however you want to say it. So we're going to take the arc cosine of x over r, and that is equal to theta. Now, all you got to do is plug this into your calculator, right? Hit arc cosine. If you have a TI, just hit the button arc cosine, and in the parentheses, type in your value x, put the division sign, the value r, in parentheses. And make sure your calculator is whatever terms your teacher wants you to have it in. This term theta could be in degrees or radians. Thank you. I'm done.